Today I want to talk about force. So imagine pushing an object with your hand. You would have a direction of the push as well as the strength of the push. And that's exactly what a vector is. So a physical force can also be represented by a vector because you have the magnitude and the direction. So for this video, I'm going to add all the previous stuff into a folder. Vector width text. So all the stuff from the previous video goes into this folder, including the scene. Put it all in there. And I'm going to create a new scene. I'll create a new folder for this. This will be vector force. And I'm going to save this scene. Save as vector force. Call it force scene. Okay. This time it'll be 3D. And I'm going to create a 3D sphere. Let me also set up a different color for this. Sphere will be red. Okay, I'll put it at 0, 0, 0. Same thing with the camera, 0, 0, 0. Slightly above the sphere and looking down. Okay. Let me also change the lighting just slightly, the angle of it. And imagine you're adding a force, which is represented by a vector. If the vector goes this way, obviously the ball's going to move this way. And depending on the magnitude, it could be 1 or 2 or 3 or 4 and 5. You can keep going. The magnitude of the vector defines how strong your push is. I'm going to add a rigid body to the sphere so we can add force to it. Rigid body. We're not going to use gravity in this scene, so it'll be like outer space. Once you add a force, the object will keep on going. I'll create a new script. Sphere. This will have... First, we need to get the rigid body. It's in the same component, so in the beginning, we just say get component rigid body. And we're also going to add a force, which is represented by a public vector3. I'll call it force. We used a function called addforce. Save, and I'm going to set up the force. First, add the sphere script. And let's say we're pushing it in the x direction by 10. If I play, okay, it's a very small force. I'll try 50. And the ball moves in the x direction. I'm going to try z with 70. Okay, and it goes this way. You can also make it diagonal or in some weird 3D position. Okay, it's going this way. But once you have this kind of vector where it's not a straight line in comparison to the axes, it's very difficult to define a force here. It's really hard to calculate a magnitude for a vector like this. Some people can do it in their head, not me. So I'm going to use a function. So instead of calling this force, I'm just going to call it direction. And I'm going to use a separate public variable called strength of the push. And in order to define the magnitude of the vector by the strength, this direction has to be 1. And we have a function called normalize, which will turn the vector into the magnitude of 1. So let's say you have a vector going in some weird direction like this, and the magnitude happens to be something like 4.6726. If you normalize this, the vector will keep the same direction, but the magnitude will become 1. So now if I go back, I'm going to have some weird direction. And the strength will be 60. And as the game starts, we have now normalized the vector. The magnitude for this vector is 1, so we just keep the direction and we multiply it by 60, which is the force. But let's say you don't want to use the numbers here, you want to keep everything visual. For example, you might want to have the object going from point A to point B in terms of direction. So I'm going to have a cube called from. We're not going to use a box collider. Make it smaller. Put it at 0, 0, 0. And let's say you want the ball to go from this position in the direction of some other random position that can be defined by these two game objects. So direction would be going this way. You can't just think of a number for this, so go to the sphere script. We'll have two game objects, from and to. So instead of punching in the number for the direction, we're going to get a vector using those two game objects. Remember from the very first video, dividing two different vectors is like getting the to and the from. Okay, once we get the direction, we normalize it. Magnitude becomes 1, and we multiply it by force. Save, and if I go to the editor, we need to drag in to and from. Okay. Now if I play, you see the ball going in this direction. Let me just set up a different color for the cubes. I'll make it blue. And we can also start controlling the cube. So let's say we're moving the cube straight forward in this direction. And depending on your arrow key, we could either add a force to the right side or to the left side. So back in the code, in the update, first we get the key. If we're pressing arrow right, we want to add force to the right. So the direction will be going right side with a certain amount of force. And that force, I'll call it side strength. This will be initial strength. Okay, if we're pushing left, the left arrow key, then we push the ball into the other direction, negative right. Save, and if I go back, so for the sphere, initial strength will be small. I just try 20, side strength, something like 5. I forgot one more thing. Let me put a delta time here. So this strength will be like based on per second. So imagine the initial force. The force is going this way, and depending on your key presses, you're adding a force to the side. So you're continuously adding a certain amount of force into one direction per second. If you keep on adding this force, eventually this arrow is going to look more like this. And the longer you hold your arrow key, it's going to continue to change until it goes all the way to one side. And if you hold your arrow key in the other direction, this magnitude is going to decrease until it becomes back to the straight line and then starts going in the other direction. Okay, so if I play, we're going straight. I'm going to hold down left. Okay, the ball's going left. I'm going to hold down right. Slowly, we're going to change the initial vector to the right side. Okay, I think the force might be a little too small to notice. Let me double it. Okay, so I'm pressing left and right and left. Let me try 20. Okay, so now it kind of feels like I'm steering. You have momentum going to the right, and you're adding force to the opposite side, which will take a bit of time for you to completely change the direction of the initial force, or the arrow of the vector. So I'm pressing right, left, and right. Okay, so you should now understand that adding force is no different from adding different vectors. And in an actual game, the physics and the character controls are a lot more complicated than this. But once you understand these basic parts, it's a lot easier for you to start building on top of it. Okay, and I'll do more in the next video. And thanks for watching.